Go. Right, so we're going to continue with our final in the series about parallel circuits for now. And we've been talking about resistors. So here's a pile of resistors. These are all 300 ohms, I believe. But we're going to talk not about resistors so much, but what would happen if we use LEDs. So here are some red LEDs. So the question is, well, we've gone through making a circuit for having one LED turn on, and we've done it in a couple of other things. But I just want to go through. This bag feels a bit odd. Making two LEDs turn on, and what are the possible ways of doing this? So here's my little circuit diagram. Not a very good one. So I'm just giving up drawing LEDs properly. So these are LEDs. They're not diodes. Well, they are diodes, but they're specifically LEDs. I just haven't drawn the little arrows everywhere. And there's a resistor, and I haven't put the value in, but it's 300 for today. So it's 300 ohms goes in there, and this is 5 volts in, and this is the ground point or 0 point over here. So if I plug this thing in, so this is the naive way of doing it. Well, this is your first way of doing it, which is to put them all in series, right? So we've gone through series circuits and parallel circuits, so you should be getting the idea. So in this case, we've got one LED, and it's followed by another LED, and then there's this resistor to limit the current. You could have like you could have two resistors, one for each LED, but you can combine them together and make one resistor, because remember, resistors in series, they're effectively the same as one resistor of a particular value. So if this was 100, you had 100 for this one and you had 100 for that one, you basically just have 200 for them both, and it doesn't matter where you put them, so they can all be bunched up together. So you could rearrange this. I think I normally put the resistor before the LED, and today I've decided to put it down the bottom just to emphasize that it doesn't matter where this goes. So it could go in here or it could go up here. So there's three different combinations that you could have for the resistor. So let's quickly make that circuit. So we can kind of do it pretty quick. So this is the long leg, so this is the positive leg. So we'll put that so that it's going from this line to this line, and then I'm just going to put this one straight onto that line. So the long leg on this one is going to the short leg on that one. Alright, and so that's gone here. So we go the current, which we won't go yet because we're missing one little piece of wire. So first we'll put, oh dear, that's too short. It's always hard getting the exact same length. This is the wrong color, but hey. So today, unfortunately, green is going to be the positive. I think you should put, in all honesty, you should put that wire in first, because then it makes it easier to pick up the hole. So the current will go in here. This is the positive rail, into this wire, through this little line here, into the leg, through the LED, then through the line back to the other one. So over to this one, through that one's legs, back here, and then we've just got to link it back up. So I'm going to make it as obvious. So we could just put this straight onto the negative, but I'm not going to. I'm just going to stick it like that. So I told you they're fiddlier when they're smaller. Alright, and then I'm going to put that one. That doesn't look any neater than the other way. Oh well, I don't care that much, so that's fine. So now I've got, I think, this circuit here. So LED, resistor, back to negative. So that's my circuit. So if I turn this on, will the lights come on? So I've got 5 volts coming out of this thing and going through here. I think it will actually come on. And it didn't come on. Oh wait, they're not pushing properly. So there you go. This does actually work. So now I'm going to try this with a different color, and we're going to see what happens. What is the time? Ooh, this is going to be a long video. Maybe we won't get through the whole thing, so I'm going to turn it off. Otherwise, it might ruin the fun. So I'm just going to take this off, and I'm going to put the blue ones in exactly the same way as I had the red one. So I'm not wiring it up differently. And these should all work. And you'll see that this doesn't actually work. But we'll just test that the circuit's working. So we'll get out this thing. We'll put that there. So I'm going to test the voltage drop across the resistor. It should say 0. And I'm going to test the voltage drop across the whole lot. So it says 4.95 volts. Hopefully you can see that, but the multimeter says 4.95 volts are being dropped across all three components. So you might be saying, well, why doesn't the light come on? But given the fact that the voltage drop across the resistor is actually very, very close to 0, it is 0, and V equals IR. So if there, what basically that is saying is that there is no current flowing through here. And that's because these things need a certain voltage drop across them before they actually work. And if we go back, think back to that video that I did before about this thing, it's always very hard. Oh, that's right, we had this problem where it didn't measure it properly. And I was going to try and work out why it can't measure it properly. But the point here is that the blue ones need about 3 volts or 2.8 or something. And if you add 2.8 plus 2.8, that's 5.4, which is a little bit more than 5 volts. So there isn't enough voltage going through these. So if you split them between the two, there isn't enough voltage. There might be enough voltage if one of them is replaced with the red one. So it works with the red LED because the red LEDs have about 2 volts voltage drop. So 2 plus 2 is 4. That leaves 1 for the resistor. And you're actually, I've gone and broken this. That's a bit odd. No, it does work. There you go. They kind of work. So that was a waste of time. So, that's amazing. Oh, I know why I said that. Okay. So, ooh, that was kind of funny. You can kind of guess why that was. I might be able to get it to do that again. Right. So, how much voltage is being dropped across the resistor? Now that we've got it set up properly, there's 16 millivolts, so there's a little bit. But they don't light up the way that you want them to light up. The way they're very, very dim. Don't leave it like that. Because there just really isn't enough. So this one's probably got a pretty good voltage drop. It's got 2.48 volts across it, and this one will have similar to that, but it's not getting as much juice out of it. 2.45. Well, obviously that one doesn't like it as much, but it's kind of showing up. If I put in the red LED, it should work a lot better. Now I just feel silly. I'm going to move this along. Alright, so they kind of work well when you do that, but that's just because these things really want more than 2.45 or whatever volts before they really get going. So they need a bit more. And this one only needs like 1.9 or something like that. So this adds up to less than 5 volts. And this is much happier, and so you get a lot more current flowing through. But of course, if you wanted to have 3 red LEDs in a row, that would add up to more than, that would be 2 plus 2 plus 2, which is 6 volts. So you wouldn't get 3 red LEDs, and you certainly wouldn't get 3 blue ones in a row working. So that's not so good. So what's the solution to this? Well, the solution is to put them in parallel instead of in series. So this is a bad circuit. This is the bad circuit. I mean, it works for some cases, but it doesn't work the way you want it. We want to have 2 bright blue LEDs and not this what we had before. So if we look at it, by the way, so that's what we want to see. We want to see 2 that look that brightness. That's what you're going to get out of 300 ohms. We just actually quickly check what is the voltage drop. So it says 2.82, so there you go. It will need 5.6 volts to get that properly. And you certainly won't get very far if you went down to 3.3 volts. with 2 in a row. But it turns out, so going back to parallel, with parallel we can easily get 2 blue LEDs lit up with only 3.3 volts. So I'm going to present 2 possible ways, there's a third way, of putting the LEDs into a parallel arrangement. So in this case here, we've got 5 volts coming in the top. So the first one here, actually we'll do this one. So the first one, we have 2 LEDs and they go off in 2 different paths, and then they link up, and then there's 1 resistor at the bottom, and that goes to ground. And the other one is that you have the LED and the resistor, and the LED and the resistor on 2 separate paths, and then they go through here. So in both cases here, the voltage drop for each path is the same. So there's going to be a 5 volt voltage drop across here and a 5 volt voltage drop across here. So in both cases there will always be enough voltage drop to get the LEDs to turn on, because they're going through separate things. So we'll do the first one first and we'll see what we get out of that. And I'm going to tell you that the answer is it will work fine. And the easier thing about doing this, if you want to put these guys into parallel, I have to bring this up close. So you put one like that, and then you just have to put the other one behind it, so that they go into, oh no, we can't do that because we're doing this circuit. Right, alright, ignore what I just said. In fact, what we will do is, we're going to have to be kind of clever. No, I can't be too clever. I don't want to be too clever because it will get confusing. So, alright. So we're going to have 1 on each side. So we're going to need a pile of these little wires. So this one's going to take so the brown one's going to go here. It's a bit of a stretch. I feel like if I just use the other side, which is the obvious thing to do, people won't quite feel that they're from the same point. I mean, we can use the other rail on the other side, but I kind of want to just stick to using... Alright, we're going to have to use... Where did I put them? Okay, we're going to use these wires here. So this one's going to go across to here, into that line. So 5 volts is going, first one's going into this leg, and then we've got another path going into this, the long leg of this one over here on this side. And then we're going to have 1 resistor for this side, and then we're going to have 1 resistor for that side, and we're going to bring in another resistor, and we're going to put that one over there, and we're just going to take that one out, making such a mess. Alright, and put that one there. Alright, so that one's going into negative, so that's basically a circuit by itself. So if I turn it on, that one will turn on. Sorry. And then we hook up the other one. So that one's just going to go with the long wires into negative. So just double checking, everyone sees what I'm doing. It goes into here, through there, through that one. That's that one circuit by itself. That's one side. And this one's going through the other side into here and doing exactly the same thing but with longer wires. So if I turn it on, we get that. And if I switch it off and put it on 3.3 volts, it still works. So even though there's only 3.3 volts and these things have like a 2.8 volt drop, just check that it's still at about 2.8. What does that say? It says 2.66. Alright. But if we went back up to 5 volts, it probably would say 2.83. So we're actually going to do an exciting video about doing science and trying to work out the effective internal resistance of an LED. So because it doesn't always have the same voltage drop, but it's because it has an internal resistance. And so we're going to try and work that out by doing an experiment, because I'm all big on science. But today, so we've done that circuit. So that's how you could get those two things. And you could just keep adding more and more on. Every time you do this, of course, there's more current going through the total circuit. It's just got different paths to take. So eventually this thing won't be able to provide the current. So there's only so many lights that you can put on before there's not enough current coming out of the battery. This battery's going to fall apart. So you can't do it indefinitely, obviously, because this is using up energy. It needs power to work. And that's only finite from a battery. So the other thing is, why do I need two resistors? Why don't I just do it this way? And the answer is, well, you can actually get away with that. So we'll just do that directly. So in this case here, I'm going to move this around a bit. So I disconnected that one. So the question here is, if I put these things in parallel, and then I have one resistor at the end, and you can do that. You can do that just by putting them on the same line, but we'll just do it this way. What I mean is, you could put it right next to that one so that they have the same long leg in the same line, and then they have the short leg in the same line, which is what I'm doing here with wires. So I don't know if you saw what I just did. So I put them in now, and that works fine, right? Like they're on, but you'll see that they're not. That one will actually lose some brightness when I put the other one in. So it doesn't look like it does. There we go. It's a little bit of brightness lost. Is that obvious that it's losing a bit of brightness? I don't think it is. We should have done it with much higher resistances. So where did I put that? It might not work with this. This is 10,000 ohms. So take that one out, and we'll just check. So it should just barely light up. So there we've got it one with 10,000 ohms. So it's barely lighting up, and if you put the other one on, it goes quite a lot dimmer. So there. And the reason for that is, of course, is that this whole circuit here is the current is mainly being limited by this part here. So this is a parallel and a series combined. So this is one part of it, this bit here, and then this is another part in the series part of the circuit. And so the current that goes in here goes through here, splits up, goes through here, and then comes back and goes out through this one here. So the same current is going through here as going through here. So in this case here, the current splits up and goes through here and then links back up the bottom. And the thing that's limiting the current is the resistors, but there's two separate ones, so they're limiting different paths. In this case here, it's the same path. And so the total current that's going to go through the circuit is going to be less than it is here. In fact, it's going to be half this. So if there's only a 300 ohm thing here, then it's the same current that would be going through as if there was only one LED. So it would go through the LED, drop a bit of voltage, then go through the resistor, and that would be the thing that's limiting the current. But it's the same thing limiting the current if there's one or if there's two, which is why it becomes a lot darker when you put that in, because it's essentially getting half the current. But the important question is what I'm kind of interested in seeing before we finish. Oh, sorry. It's like lighting failure. How much time have we got? We've got 9 minutes, so this is going to be a long video. So I'm going to do one more thing, and the important thing is, what if we do this kind of circuit, but we have two different types of LEDs. So we have an LED, a blue one with a voltage drop of about 2.8, and then we have a red one with a voltage drop of about 1 point something or other. But they're going through here and there's no resistors. So as I said, that both paths will have the same voltage drop, but you're going to end up forcing one of the LEDs to have a different voltage drop. And this is actually why this is a much better way of doing things. because, well, as you get into more complicated circuits, this is much better because you can turn one of these off and it won't affect the other one because the same current is going to be going down here. So it's the current going through one particular branch is limited by that resistor. It's not limited by the other resistor. So if this branch just disappears, the same current will flow through there and the same brightness will be on the other one. So if you have something that's electronically turning something off, it's not going to affect the brightness of the things that are still on. Whereas here, if you turn that one off, then this one's got all the current and it will become brighter. So that's one problem, but the other problem is if there are different types of LEDs. So we'll come to that in a second. But the other circuit that I was going to mention is this one. So you could, if you really wanted to, you could get back to this and have the same brightness. So in this case here, if you have 300 ohms, and these are all 300 ohms in my circuits, this is going to be half the brightness that it is over here because these are both sharing the same current. In this case, they're splitting it. But you could lower the resistance by putting in 150 ohms. So you could do that by making a parallel circuit with the two 300 ohms, and then you get 150. This is essentially 150 ohms going through here, and then you get the same brightness that you'd have in this circuit, but you'd still have the same problem that if one of these was turned off, or they're different types of LEDs, you'll have problems. So if this one was turned off, then you've only got 150, so it's still going to double in brightness. It's just going to be brighter than it was in this case here. So that's another way of doing it. That's a parallel and a parallel in series. So I thought that was interesting. We're not going to make that one, but we are just quickly going to finish it off. So we're going to go back and we're going to get this one working again with 300 ohms. So lots of complicated wires, and then we're going to take so actually, to me, these look slightly different in brightness. So one of these is slightly dimmer than the other one. But we're going to replace it with a red one. So we're going to take this one out and we're going to see what happens. So I'm kind of interested. I'm assuming that what will happen is that the extra voltage is going to have to be used. It's going to be going across the internal resistance of this. So we'll put it in and we'll see what happens. This probably might put a strain on the LED and might break it. So you've got it the wrong way around. So the long lead goes there. And so, there we go. So actually what happened is there's enough voltage to go, which actually makes sense now that I think about it. There's enough voltage to go through the red LED. So 2 volts is good enough to get this one here. So all the current can now rush through here, but at that point, this is still impossible to get through because it's not enough voltage to get across here with any what's the right word? With much luck, I don't know, with any great amount. So what has happened is the total voltage drop will be across here will be determined by the lowest voltage drop required to get through here. So that will mean that there'll be 2 volts to get across, say this is the red one, 2 volts to get it across the red one, and then they'll end up with 2 volts across the blue one, which isn't enough to turn that one on. And so all the current is going to flow through here. And we can just double check that. So there will actually be a voltage difference across the blue LED. It's about 1.95, which is what which is exactly probably what the red LED requires, which is not going to be enough to. I can't do that. But if we measured the current that was going through that side, it would be pretty much all the current is going through there. Like no meaningful amount of current is flowing through the blue diode. There's a small bit of leakage because everything is not perfect, as they say, but it doesn't matter. It's negligible. So that's another reason why this circuit doesn't work, because if the voltage, that will go through the voltage thing, the thing with the lowest voltage drop. So the difference between this and resistors is that these are non-linear, I think that's the term, non-linear devices. So they're kind of fixed. They always sort of have the same voltage drop, roughly the same voltage drop. In all cases, whereas a resistor is free to change. So that's different from the resistor parallel circuits and series circuits that we did in the previous video. But anyway, I hope this kind of makes sense. Don't make circuits like this unless, for example, you might be doing a circuit where you have like a red light going backwards and forwards, and if they're all red or they're all the same color, in fact probably if it doesn't really matter too much, then you can kind of get away with just using one resistor. So we will go through making the little lights going backwards and forwards circuit. It's a very common one, uses very common bits and pieces. In that case, you don't really need a resistor for every LED, because only one LED is ever on at a time, and so there's only a need for one resistor. So you could use this kind of circuit when you only have like one LED on at a time. But in general, you will have to do this kind of circuit. So you have one resistor for each LED, and they all break off and they branch off like that. So anyway, I hope that was interesting. This actually took me a while to get, so I was always wondering, because you make these circuits and they have lots of LEDs, and you always end up putting one, resistor for every single LED, and it just seems like, wow, this is just ridiculous. Why can't I just use the one? And it took me a while to actually get my brain around it, but now I have, and I hope that you have too. So anyway, actually, we'll just quickly, last minute thing, I'm going to put a yellow one in, and I'm going to see what happens if you replace the blue one with a yellow one. So I think the yellow ones have a similar voltage drop to the red, so I'm guessing that it's going to come on like the red one, and it does. So there you go, they've got a similar property, so that works with those kind of things. Oh, actually, well, we do need to do one last thing, don't we? We can do it real quick. So I have to prove that what I just said was true. So I'm going to quickly convert this into the parallel film. Like that. So they're now in parallel, so we've now got this circuit, and we've only got 2 minutes left, and then we're going to replace the yellow one back with the blue one I just had, and so you're going to see, even though they have, remember they go the one way around, not the other way, even though there you go, and if you really want to be quick and dirty, you can get the other one to go in so you can combine the two different types of circuits like that. So you can try and work out what I just did by thinking about these two things. So basically I've got this for the yellow and the red, and then I've got this overall. So the blue one's on a separate line, these two are linked together, and they're in parallel because both legs are on matching lines. If that's all clear, you can see how it's going there. So yeah, so thanks for that. I hope that was kind of cool and interesting. Sorry, the battery's dodge. Like, share, subscribe, that kind of stuff, and catch you later.